Okay, number 15 is a problem from lesson 63. I'm going to remind you that we just learned the formula for finding arc length. Whoops. And that formula was S equals R theta. Let me just interpret this. This S has to do with the arc length. The R stands for radius, and the theta stands for the angle, technically, of the arc. But we're not going to call it the angle. We're going to call it the radians, okay, that have been traveled. All right, so just remember that particular formula. Now it says Jupiter is the largest planet. It gives the radius of Jupiter. Jupiter rotates faster than Earth. It says it takes approximately 9.8 hours for Jupiter to make one complete rotation. Okay, so what I'm going to draw is just the path of Jupiter's rotation. Okay, so let's just say this is Jupiter's rotation. We know that the radius here is 44365 miles. So it says if an object is fixed on Jupiter's equator, how far does it travel in 1 hour due to Jupiter's rotation? So basically what we're asking is how far would this travel? Well, if it travels all the way around, how far would it travel? And then how far would it travel in just 1 hour? Okay? So you could solve this using the circumference equals pi times diameter formula and think through it that way. But since they've given us this arc length formula, I'm going to solve it using this method. Either way is completely legitimate. So how far does it travel? And that's what we want to know. How far along this path of rotation does it travel? Certainly not the whole way around, because it takes 9.8 hours for it to go the whole way around. So this is what we're looking for. This is our unknown, S. We know the radius is 44,365. Okay, and so the last thing we need to do is to figure out what the theta value is. So let me remind you that we know this to be true. One rotation occurs in 9.8 hours, okay? Now, what I am reminding you of that you probably just learned today or a couple of days ago at the earliest is that one entire rotation is called 2 pi radians, okay? So one entire rotation is 2 pi radians, okay? So to change this, to figure out how many radians are passed through in 9.8 hours, we know that it takes, they cover 2 pi radians in 9.8 hours, because one rotation is equal to 9.8 hours. So let's just write it like this. We know that that's 2 pi radians in 9.8 hours, okay? So that's where we're going to get this theta value in radians. It's 2 pi radians over 9.8. Now, radians are technically unitless, so this unit here we wouldn't even have to write here. So we could actually just write it as 2 pi divided by 9.8. And when all is said and done, you should end up with 28,444 miles. And that's how far the object has traveled in 1 hour. Okay?